Welcome everybody to the afternoon session, PyData London, day 2 after tutorials yesterday, or the first day of the actual conference. I'd like to talk to you today about running Python in the browser. I like running Python in weird places, and I think the browser is probably the weirdest where you can run Python. This is not a project that I came up with, but I picked it up when it was announced, and I built some applications on top of it. And I think it's a really fun environment to play with Python. And I try to persuade you of that. So that's my goal for today. So who am I? I grew up in the Netherlands. I got my master's degree and PhD there. Then I moved to the US. I worked at technology and banks. So IBM Research was the beginning of my career, then Morgan Stanley, then back to the Netherlands for a bit. Then I joined Bank of America, where we built a large trading system or platform in Python that ran all of the trading in Bank of America or Merrill Lynch. So this is an investment bank where you want to have a single representation of what is called an instrument. So that is an asset, or like a stock or a bond or an interest rate. And these are things that you trade. So you sell and buy from other people. So at some point you want to know how much is it worth. So you need a function on that that's called price, and you have some attributes that you pass in. So if you have different implementations in different parts of the bank, then predictability becomes a problem. And your numbers cannot be compared or compatible, and you cannot calculate your risk reliably. So there's a lot of efforts in large banks to come up with single instrument representation. And the project I joined in Bank of America is called Quartz, where it tried to do that in Python. Later on, if you step forward a little bit, I'm at JP Morgan again, which is Athena. So this is sort of a reverse time series. Okay, I joined iteration 3 of this project, and then later on I joined iteration 2. So I saw it was like an alternate reality. There's only really one way in which you can solve this problem, and all these banks are trying it on their own way. I also worked at Google and Uber, so I have a mix in both technology and finance, but I'm not a quant or something like that. Today I work at ADIA, which is based in Abu Dhabi in the Emirates. And that's a sovereign wealth fund where we manage money by trying to do systematic trading and make more. So you can understand that that requires a lot of data science, because you have to gather a lot of data from outside, make decisions based on it, and then come up with trading strategies that you apply. In all of these worlds, there are 2 different kinds of people. Let's just make it black and white. So there's 2 kinds of people. There's economists, there are data scientists, there are quantitative, there are mathematicians, and they like to use Jupyter notebooks. On the other side, you have people in production that like to have predictability of the results. They want to have standardized Python. They want to have reuse. They want to have not copies of things. And they want to run at production scale, because you have to manage a lot of data. And these are like aliens. They cannot talk to each other. So that is my goal in life, is to sort of get them closer together. In parallel to doing work, I also like communicating. So I've written quite a few books. The most recent ones are not about technology, but more about how do you communicate better as an engineer. So there are a lot of channels that we use to communicate with as engineers. I'm assuming that most of you are engineers here. And we communicate with people that don't understand us. We want to talk about register allocation and not about what is the value of the software to the bottom line, whatever, right? So there's a lot of opportunity for engineers to become happier, more successful, richer, if you can actually talk to these people. So that's, at some point I started collecting all these tips and ended up in a book. The other book is written by an AI, so you should maybe take a look at it. I'm not trying to make any money on this, on the second book, so it's sold for, printing costs. Because this was an experiment. When ChatGPT just came out, I wrote a book together with it. So I asked all the questions and all the answers were given by ChatGPT. We'll use AI in this presentation as well. Not just for creating the slides, but we'll use it to generate code, and I'll explain how that works. Because I think that's the future, where we collaborate with AIs to add value quicker, maybe bring these two worlds together. So why PyScript? So I'm showing you some applications of PyScript. So what is PyScript actually? So PyScript is coming out of a need, is that we want to have an easier way to develop web applications. Python is very popular. Who here uses Python? Yeah, everybody, of course, yes, because this is a Python conference. But if you look at things like LinkedIn, you scan all the jobs and you see what languages do people require, Python is on the top. And there's many ways in which you can do these kinds of calculations, and Python often comes to the top. So it's a very popular language. Also, it comes with a lot of batteries. So there's a lot of development over the last 30 years or so that Python has been around, specifically targeted towards data analytics. So data manipulation, data visualization, natural language processing, where everything has been solved. So it's a lot easier for you to build value and add things on top because there's so many batteries already. But there are also too many batteries. It can be overwhelming to pick the right one. There's more than 500,000 projects on PyPy right now. And if you see the download stats, it's like, I don't know, 30 billion a month. So this means that people download Python packages a lot. And why is that? Because they have to create an environment where all the versions of all the packages that they require recursively have a predictable outcome so that the next time you run it, it's a reproducible result. So this is an AI-generated picture. I asked it, like, why is Python installation a pain? And it came up with this picture. And it's apparently such a pain that this is probably XKCD reference, where Python can fly, somewhere in the XKCD. And it's such a pain that it actually writes your code on the wrong side of the laptop. So this is like, but it's a reality. Like, installation of Python packages is hard. And when there's a problem, you solve it, you make another tool, right? So UV solves everything now. Not really. It still requires, if you want to have your application delivered to people who are not Python developers, and you say, well, oh, it's easy. You just do UV in and run, and say, okay, they give up, right? So this is too hard to develop your applications and deliver it in one button press. And this is what PyScript tries to achieve. So we want to have Python available everywhere without any installation. So how do you do that? You make a web application. So the web application is a link. People click on the link and it works. So how does that work? There's a little bit of JavaScript that bootstraps the download of the WebAssembly containers for the 2 Python VMs that are currently supported in PyScript, which are MicroPython and PyOdide. And these are then bootstrapped with an empty container. And they say, like, well, I need my all the basic libraries from Python, like definition of string and all of that. And then it builds that up, and you say, well, I also want pandas, I want this, and also downloads that from PyPI. And then installs it on demand in that container. And at that moment, your Python code is then executed and runs in that container. It can talk to the JavaScript engine to access the DOM. And in that way, you can actually render things in the browser. So this is the basic process without any manual installation. People just click on a link. Behind the scenes, the PyScript runtime, the JavaScript bootstrapper, will kick off the right VM, the one you chose, and then it will bootstrap your application. So why do we have 2 VMs? There's actually, you can do any, but there's two popular ones, MicroPython and PyOdide. So MicroPython is for embedded devices. It's a really tiny Python VM, and it measures, libraries included, like 240K. PyOdide is much bigger, and it has everything in the language. So to get it working on an embedded device, you say like, well, for string, there are like 70 functions, right? Of 70 methods you can do on a string. We don't need all of them on embedded, only maybe 30, right? So you selectively cut down the size of the library and therefore also the capabilities of the VM to make it as small as possible. And PyOdide says like, no, we're supporting all of Python. So this is a standard CPython VM. And that has been compiled to WebAssembly. So normally Python runs on Linux, on macOS, on Windows. And somebody wrote the makefile to say like, how do you compile into a native application, right? The CPython VM is a C program, and you can compile it to native instructions and bundle it up and then make an exe out of it or an executable format for Linux. And this is what somebody has done. So they have written the makefile basically for WebAssembly for the PyOdide VM. So your Python code is not converted into WebAssembly. That just runs as before. And it's the standard Python VM, so its compatibility is one-on-one. But it comes at a price. It's much bigger. And I said in the beginning, you start with nothing, and it has to like import everything and build in there, because for security reasons, you start with an empty sandbox. So that's the trade-off, startup time. And you will see this coming back later. So to get started with PyScript, we always recommend people to go to PyScript.net, which is a starting point. It gets you to Discard, it gets you to examples, it gets you to documentation. And I'll show you two examples of standard examples that come with PyScript that show you the power of running Python in the browser. The first application you've already been watching, this slideshow, is done as a PyScript application. So I wrote some Python code that downloads a Google presentation, extracts out the pictures, puts them in the file system, and then I have Python logic that says like, oh, you press the right key, I go to the next one. Oh, you press the left key, I go to the left. And it even works with this remote. This is really interesting too. So I can go and back and forth. So it's almost like Google Slides, but then all written in Python, right? Why would you do that? Well, it's just fun. So the first example, you go to PyScript.net, and it will link to the documentation, as you see in the bottom here, but it also has a link to examples. And this is what I did. So I opened the first one. And this is basically a poor person's IDE. You can edit Python code in here. So you can see it here. It's in an editor. And when you make changes and you save and you run, it runs here in the browser. Now this is using WebGL, and it's really, like I mentioned earlier, from the Python code, you can get to the JavaScript runtime and then to the DOM. So here we're using a JavaScript library to do that for us. So from Python, we basically just instantiate that WebGL library. And you can see how it works here. In the top, we say import 3. And then from 3, we say get a WebGL renderer. And we basically write the same kind of code that we would do in JavaScript, but now we write it in Python. But it's really executing JavaScript. So there's a proxy between the two languages, between the two runtimes. And anytime you make a call from Python to JavaScript, we create a proxy, and then we say to the other side, like, I want to have the WebGL renderer on 3. And it will create a proxy on the other side for us to hold on to that result of that execution and send back the proxy so that now we can say, I want to call new on it. And then, so we go back and forth between these two runtimes all the time. So anytime you see a dot here, that's basically going between these two runtimes. And once it runs at normal speed, maximum JavaScript speed, basically, which is pretty fast these days, actually, because V8 is over-optimized. It's just unbelievable. So this is the basics. This is one thing you can do. You can very easily use JavaScript libraries and script them from Python in this way. So this works because you have an index.html that says, at some point says, I have a script tag here. Can I zoom in a bit? Yeah. So the script tag looks like this. So it says like, what I want to run is PyOdide. Here's my source file and here's my configuration. So this is like a JavaScript script tag, but in this case we say the type is Python. And then it just bootstraps on top. So this is one example. The other example is using a Python library called Folium. And this is often used in Jupyter notebooks for rendering the result of geographical information system related data. So in this case, we have the map of the US and we overlay it with some data. So this is this whole script here. But this one doesn't go to JavaScript, but it keeps talking to Python libraries. So I installed another package in my PyScript.toml. You can see that one of the packages I install is called Folium, and the other one is Pandas, because those are the two packages that my code needs. And my code imports Pandas and it imports Folium. And it basically downloads this data from this location, turns it into a Pandas data frame, and then it gives that to Folium to render a map, and it basically extracts the data out. So now when you look at this, normally in Jupyter Notebook, what it generates is HTML. When you say display, this generates HTML, gives it back to the Jupyter Notebook, and it renders it in the document in place. But what is rendered there is HTML that is generated by the Python code that was executed. And this is the same way. So from inside your web application, you can run Python code that generates HTML, and then you basically host that back into the DOM. So when I interact with it, this is, again, JavaScript. So this is not using Python event handling, and Python isn't drawing these rectangles, whatever. At this moment, it's all done by JavaScript, the same way that you would have in a Jupyter notebook. So you can combine these things. You can write pure Python. You can write Python that uses packages that generates JavaScript code, or you can directly go to JavaScript. And you can mix and match at any point which you like. Chris. Yes, a question. Yeah. Jeroen has a question. Wait a second for the microphone, please.
Yes, could you please go back to the previous example? So 2 examples back.
This one?
Yes. So there's line 54, there's a script tag. But is this all that's needed, or is there some other JavaScript view?
Oh, yes. Yes, at the top, that's a good question. At the top, there's some initialization happening. All right. So you need to install PyScript, and that is done with this URL. And this registers itself as a content handler for the page. So it gets notified when a script tag is included in the page. So that JavaScript code then takes out that main.py and it starts up the VM and bootstraps the VM with that. Yeah, so there's a little bit of setup at the top here.
Makes sense.
Yep. If you're interested in doing this yourself, you just go to PyScript.com. So this is running on PyScript.com if you look here. And this is from the examples folder, but you can also create your own examples very easily. So you just press the new button and it will create a new example, and so you don't have to know how to get bootstrapped with this process. Another example is, so I showed you a screenshot of this, but this is actually my home page. And this is also written as a PyScript application. So there's some animation that is happening here. When you move the mouse, it's allowing you to click on things. So why would you write this in Python? Because I could. I thought it was really cool. And you could have done this in JavaScript, of course, but hey, come on. If you look at inspect and then at the source, maybe I should show the page for source. You can see that I use some JavaScript and then I use main.py. So this is my code for my personal homepage, written all in Python. That's awesome. Another example is based on work I did at JP Morgan when I was employed there. We had, I mentioned these large trading platforms and these large applications, and we start millions of them every day. And they take a long time to start up. And I wanted to save money, or the bank money. And I thought, like, how can I make this faster? So I wrote a profiler. It's a sampling profiler that runs in production on these apps. And it records whatever is happening. And then there was a UI written in TypeScript that renders it. And then PyScript came out, I left JP Morgan, and I thought, like, I want to do that thing again, but not use TypeScript, but I want to do it in Python. So this was my first experiment that I wrote with PyScript. So you run the sampler, and that's already installed actually on my platform, on my laptop here. So anytime Python runs on my laptop, it creates a recording of that execution. And they automatically show up in this table on the left. And then I can basically browse them back. So this whole thing is written in Python. So there's no JavaScript here. This is all real Python. So this is an example of the other extreme. I'm not leveraging any JavaScript libraries because I wanted to see how far can I push it. And this was horribly slow. Because I mentioned before, like whenever you have a dot, you go from the Python VM to the JavaScript VM. You have to create a proxy so that they can talk with each other in the future. But I also have to marshal all the arguments. Like if you send a string from here to there, we have to encode it in a format that both understand, and JSON is the best one. So there's a lot of conversions happening. So if you imagine you draw this whole diagram, there's a lot of draw line instructions, fill box, draw text. And each single one is not that expensive to go across, maybe 50 nanoseconds. But if you have 1,000 of them, or 10,000, it adds up, and it's more than a second. So this thing was horribly slow, like boom, boom, boom. So I had to make this faster. So the current speed is, it's actually, I cannot like disconnect it from the mouse. This is how fast it renders. And every time I move the mouse, it re-renders the whole page. So this is, and you zoom in, it does the same thing. So this is more than acceptable for the performance that I was aiming for. So the way this works, it collects all the draw rects, it collects all the draw strings and all the draw lines, and it basically wraps those as one instruction. And I say, I want you to draw purple boxes in these locations. And it's just a nested array of 4 integers. So now I need only maybe like 5 or 6 round trips between these 2 VMs to render it fast. So I'm cheating. I have a little bit of JavaScript at the back end. So it's like my native code, right? In languages like Java, you write C code. In Python, you write C code to make that little bit faster. In PyScript or PyOdide in the browser, you would use JavaScript as your native code to make it faster. Now, what can you do in this thing? Like, yeah, it records everything. It also records the logs. So this is interesting. You can combine the two. So you can look at the timeline, what happened here. So this is like a log entry. You can screw. So this is all Java. This is not JavaScript. This is Python. So this UI is drawn by Python, and it's at this moment, this is all in the Python memory, where I'm like looking over this historical data. And you can do things like, what does this program do? If I ask you, right? You don't know. It's called images, so maybe it does something with images, you don't know. But it runs for a while. You can see here it does pyplot for a while, and then it runs process image for 5 seconds. So this is coming back to that example that I mentioned earlier at JP Morgan, where we have startup took so long, and I didn't know why. In Python, we pay the price for imports, and they're often hidden. So if you look at this example, data frames, this is an example where I wanted to do something with pandas data frames, and it took like 15 seconds to just import pandas. At the top, you can see a CPU was 0. So this is just waiting for I/O. The yellow line shows you the number of packages loaded so far. So it goes eventually to something like 626. So in order to do one thing with pandas, you need to load 600 modules. And each one is a Python file. And each one has to come from the file system. And this is all I/O. I'm just waiting for the bytes to come in. Now, why it was so slow this time, I have no idea. It's not normal to take 15 seconds. But at least I know now that it comes from I/O, and I need to have better caching on my local file system or something. But if you want to know what this thing does, like this images example, I can look at the design, and this is quite interesting. So what I do here is, this is drawn with D3.js. So I'm cheating, I'm using JavaScript, but this is the possibility, right? I can switch between Python code and JavaScript, whatever is the most practical at that moment. Like Python doesn't try to solve solved problems. We leverage what is available anywhere. But from this I can now very easy, I can sort of get an idea what this program is doing. And if I don't, then I can always ask the AI. So OpenAI, what is this thing doing? And it looked at that trace of the execution, and it just gave me a description of what the code does. So this was my first experiment. I did a tutorial in December on PyScript online, and there I wanted to also use AI. So we have to use AI, right? So this UI is written in Python, and it goes out to OpenAI to basically help me with setting my goals. So it says here PyData London, but let's say like I want to get promoted. So it's trying to find a picture for trying to get promoted. Takes a little longer, it's like 15 seconds on average. The text is easy to generate, apparently. So it gives me some idea of what I can do to get promoted. I have to understand the expectations, requirements. Oh yeah, that makes sense. I have to research, this all makes sense. And then, the picture still has to be worked on. But your goal has to be achievable and relevant and miserable. But anyway, you get the feeling. So how do you do this? This is like 30 lines of Python, this whole app. So it's very easy to construct. Because you don't have to learn any JavaScript. This is, if you know Python, this will feel like very familiar territory. So to build that last step, I wrote a UI toolkit because it's really hard to write UIs in a very low level on the DOM level, like create DOM entries and whatever. I wanted to have a higher level abstractions. I wanted to have reactivity. I want to have a model and then have widgets update automatically when the model changes. And because we're writing Python code, this is actually not that hard. So on the right here, you see I introduce a class. It's a Python class. And then I basically write a UI. So it says like I need a vertical box. Inside I have a label. And then I have an input which refers to the name of the product. So this is the first line. And you can sort of see the structure of the code already. It's a vertical box with little things in there. And now when I make changes in this model, so if the name changes, all the UI elements are dependent, like React.js. And then this string updates. You can also do this from code, so you can like make some changes in the model and then directly, and then the UI gets updated. Now this is easy to write. It was very easy to do. This library is called LTK. It's the little toolkit. So if you go here, it shows you the repository. So you can actually look at the code, and it's not that hard. It's this is the biggest file. This has a definition of all the widgets in LTK, and it's like, let me see, 1,700 lines. And this is the most complex one. The rest are much smaller, like 100 lines and 50 lines. So that allows me now to build up more interesting abstractions in Python to build, bigger applications. I also mentioned that we have MicroPython and we have PyOdide. And this is an example where you can do that. So here I'm running with PyOdide. Now I'm switching to PyOdide, and you see it takes a little longer. So it has to construct the Python VM, bring in more stuff. I can run more, but that's a trade-off. I've also built Python visualization in the past. This was like 2015. I did it on AppSpot. And this is a version that runs entirely in the browser. So you can also do sys.settrace on your application. So anything you can do in Python, you can actually do within the browser. So then you can build very interesting visualizations like this one. And this one is calculating the golden ratio. And it sets a breakpoint on this line. And each time the breakpoint is hit, we run the visualization script at the bottom. And this is updating the view on the top. So I can go back in time and basically see the picture. So if you ever want to know what the difference is between breadth first search and depth first search, so this is breadth first search. So you can see it, right? It's like horizontal, but you can also hear it. So think about how this here like sounds. And now I'm going to switch to depth first search and see how the sound is different. So this helps me understand how the program works. And again, this is a little bit more useful way of running Python in the browser because I don't need a server to run the algorithms and visualize them. It would have been quite hard to do all of that in JavaScript. So this is a very good example of why you want to do it there. Okay, I want to get promoted. This is another example of an application that I thought like I was going to get really rich with. Nobody bought it. It's called lifesaver.coach. So if you're interested, go there, buy a subscription. To get promoted, it gives you advice here and so on. I can click this thing and this will make a task out of it. So now I know I have to work on this and then I'm done with it. Yay. Next slide is, I already got the notification of the time. So the next one is Jupyter Notebooks allow you to write Python code and run it sort of in the browser, but it runs in a kernel. So this is, if you've heard of Python for Excel, Python in Excel, this is like Python in Excel, but this is Excel in Python. So I've written a spreadsheet here in Python using LTK. And it's basically building the dependency graph of execution, but all the Python code runs in the browser in WebAssembly here. Why would you do that? Because I wanted to prove that I could. And it's using two VMs. It has MicroPython for the UI, and it has PyOdide for the worker. And it can do anything you can do with pandas, polars, whatever. So here I'm loading URL. So if I go here and basically grab that one quickly. So if I have this URL and I go to a new file, for instance, start with an empty sheet, I can say import and then pass in that URL. And it will do a preview of that. And then I can import it into the sheet. I can do a pandas or polars. So I got the Polar guidebook authors here sitting in the first row. So this is for you guys. This is polars. Here we go. You can also use DuckDB data frames. And here I experimented with some interesting filtering. So here we have, like the coordinates are filtered by 14,000. So let's change that. So I say instead of 14, I want to have 15,000. So when I say enter, it actually updated the source code here and then redrew the map. So now I have fewer ones. So that is all cool, but it gets even better. So I gave a demo of this to Guido, and then he said like, yeah, it would be really cool if you can actually interact with the sheet from the cell, right? And he said, like, I tried to like negotiate that in Microsoft, but they wouldn't let me do this in Excel. So I said, oh yeah, that's possible, let's do that. So what we have here is a cell function, and here's the code. And what it can do, it can escape its sandbox, and it can talk to the sheet, and it can update DOM entries in the sheet. So this is what I'm doing here. I can also set event handlers. So I can say, move the piece from here to there, and then move from here to there, and then move my queen here. And this thing is really dumb because it moves randomly. So it's easy to win. But try and do this in Excel, right? Try to do this. I tried to actually hook up a Python engine as well, a game engine, but those are mostly written in C. And they're not pure Python, so they're hard to import. So here you can see I import chess as a module, and there are chess engines that are compatible with chess, the Python module. But they wouldn't run in WebAssembly, so I'd have to compile the C code to WebAssembly first, and that was a little bit too much work. Now, so that is some of the things that are possible, but people were complaining to me like, oh, that looked like Excel. Can you do all the key bindings for Excel? No, please not. Do you have all the imported default functions in Excel? No, let's remove the sheet, right? So this is an experiment that I did, is similar. So this is again MicroPython for the UI. It's using PyOdide to run the code, and it's using another PyOdide for finding out all these components. So this palette is done by one VM, and then it runs. And why? You have to talk to me afterwards. We can talk about that. So what I want to do is I want to draw a picture. So I want to draw a candlestick of some historical data. So what I need is a data frame. So I click on data frame. I want to connect it to something. And there are two potential candidates. So history is one. So I create history. So now I can connect up my history to my data frame. And this history object needs a symbol and from date and to date. So I luckily have components hanging around that match those things, so I can connect them. So Tesla symbol, from date, and then to date. And when I click, it now has all the three inputs, and it can actually run. So you will see it run that cell. So it ran the pandas data frame creation code for that. And then it gave the output to the input of the candlestick, and it could draw itself again. Now this runs up to March, so let's fix March and make it a little bit later. So like today is 0607. And when I change, the input changed, and then the data frame will be run again, and then it's updated again. So there was some recovery, and now we're going down again. I wonder why. So this is what is possible with Python in the browser. These are some examples that I gave you. If you're interested in trying them out yourself, this is all open source. PySheets is open source. The Flow example is open source. So just head down to the GitHub logo, and you'll see the repositories there. My plan was to, or my goal for today was to get you excited about running Python in the browser as a replacement for JavaScript, because I think Python is a much nicer language. We all agree, right? So with that, I want to thank you. And if you have any more questions, I guess we almost ran out of time, or we ran out of time. So come to me in the hallway, and we'll have some discussions on this. So thank you.